victory in World War II would have freed Nazi Germany from the desperate constraints of multi-front warfare and allowed its military and industrial complex to pursue technological development without the pressure of imminent defeat. The question of what Germany's military and technology would have looked like in a post-victory world isn't pure speculation. German engineers and military planners had extensive programs underway, prototype weapons in development, and theoretical designs on drawing boards that reveal their technological trajectory. Understanding this trajectory requires examining projects already in development during the war, the ideological and strategic priorities that drove German military thinking, and the practical constraints that would have shaped development even in victory. What emerges is a picture of impressive technological ambition undermined by fundamental strategic misconceptions, resource limitations, and the irrationality that characterized much Nazi decision-making. The immediate post-war military posture. In the immediate aftermath of a hypothetical German victory, the Wehrmacht would have been the most powerful military force in Europe by sheer weight of numbers and combat experience. Millions of battle-hardened soldiers, thousands of tanks and aircraft, and extensive fortifications across occupied territories would have given Germany overwhelming conventional military superiority on the continent. However, this massive military would face immediate challenges. Maintaining millions of men under arms would strain even a victorious Germany's economy. The transition from wartime to peacetime economy would require demobilizing much of the Wehrmacht while retaining enough force to occupy and control hostile territories across Europe. German military planning in a victory scenario would likely have followed a model similar to other continental empires. A relatively small professional force of Germans would form the core, backed by larger numbers of conscripts from occupied territories deemed suitable for military service. The SS would expand its role, functioning as an ideological and racial elite military force stationed in the most sensitive occupation zones. The immediate priorities would be suppressing resistance movements, securing critical resources, and establishing permanent garrison systems across occupied Europe. The initial years after victory would see German forces engaged in continuous counterinsurgency operations, particularly in Eastern Europe and the Balkans where resistance would be most determined. Naval power would become a priority in ways it hadn't been during the war. If Britain had been defeated or forced to accept German dominance, Germany would need a navy capable of securing its maritime interests. The Kriegsmarine would expand, shifting from submarine warfare to building a surface fleet capable of power projection and securing shipping lanes. Air power would remain central to German military planning. The Luftwaffe would transition from tactical support of ground operations to strategic missions, including long-range bombing capability, air transport for rapid deployment to trouble spots, and air superiority platforms. The jet aircraft programs already underway during the war would be accelerated and refined. Jet aircraft and advanced aviation. German jet aircraft development was already advanced by the war's end in our timeline. The Messerschmitt Me 262, the world's first operational jet fighter, had entered service in 1944. The Orodo AR-234, the first jet bomber, was also operational. These weren't experimental prototypes. They were production aircraft that revealed German engineering capability in jet propulsion. In a victory scenario, these aircraft would have been refined and mass-produced. The Me-262's initial technical problems, including unreliable engines and short service life, would have been addressed through continued development. Engine metallurgy would have improved. Manufacturing techniques would have been perfected. The result would be a formidable jet fighter significantly faster than any piston-engine aircraft. The strategic implications would be significant. German jet fighters would dominate European airspace. Any potential adversary would need years to develop comparable aircraft, giving Germany air superiority for the medium term. This would complicate any potential future resistance or intervention against German control. However, The Me-262 also revealed fundamental limitations in German jet technology. The Jumo 004 engines had service lives of only 10 to 25 hours before requiring replacement. This wasn't a problem easily solved. It reflected fundamental metallurgical and manufacturing limitations that wouldn't disappear even in peacetime. German jet engines would remain maintenance-intensive and unreliable compared to later jet engine development in other nations. Beyond the Me-262, German designers had more advanced projects in development. The Horten Ho 229, a flying wing-jet fighter bomber, was an extremely advanced design that anticipated later stealth aircraft principles. Several prototypes had been built by war's end. In a victory scenario, this aircraft might have entered production, giving Germany a jet bomber with long range and unusual radar cross-section characteristics. The Messerschmitt Me-163 Comet, a rocket-powered interceptor, represented another German technological direction. This aircraft was incredibly fast, but had extremely short endurance and was exceptionally dangerous to fly. In peacetime, it would likely have been abandoned in favor of more practical jet designs, but it demonstrated German willingness to pursue radical technological solutions. Transport aviation would have seen major development. The Luftwaffe had struggled with airlift capacity throughout the war. Jet-powered transports would be developed to rapidly move troops and supplies across occupied Europe. This would be essential for responding quickly to resistance activities in distant territories. Strategic bombing capability would become a priority. Germany never developed heavy bombers comparable to American B-17s or B-29s during the war, focusing instead on medium bombers for tactical support. In peacetime, with potential adversaries across oceans, Germany would invest in long-range strategic bombers. Jet-powered designs would be developed with intercontinental range capability. The America Bomber Project, which had been pursued intermittently during the war, would likely be revived. This was a program to develop aircraft capable of bombing the United States from European bases. Various designs were proposed, including some with transoceanic range. Whether these aircraft would actually be built would depend on the strategic relationship between Germany and the United States in this alternate scenario. Helicopter development would accelerate. Germany had developed the Flettner FL-282 and Fokker-Aegis FA-223 helicopters during the war, primarily for reconnaissance. In peacetime, helicopters would be recognized as ideal for counterinsurgency operations, allowing rapid deployment of forces to remote areas and evacuation of casualties. German helicopter technology would advance rapidly. Missile and rocket technology. German missile and rocket technology was significantly ahead of other nations by the war's end. The V-2 rocket, developed at Peenemünde under Wernher von Braun, was the world's first long-range guided ballistic missile. Over 3,000 were launched during the war. This represented a technological achievement that presaged the space age and the nuclear missile era. In a victory scenario, V-2 development would continue. The missile's range would be extended. Accuracy would be improved through better guidance systems. Payload capacity would increase. Within a few years, Germany would likely have ballistic missiles capable of hitting targets across Europe with reasonable accuracy. The strategic value of these missiles would depend on the warheads available. With conventional explosives, the V-2 was a terror weapon with limited military utility. The enormous cost of each missile relative to the damage it inflicted made it economically irrational. However, with nuclear or chemical warheads, ballistic missiles would become strategic weapons of enormous importance. Surface-to-air missiles would be developed to defend against potential aerial attacks. Germany had been working on guided anti-aircraft missiles, including the Wasserfall and Rheintochter projects. These would be perfected in peacetime, creating an air defense network that would make attacking German territory extremely costly. Anti-tank guided missiles would be developed to maintain German armored superiority. As potential adversaries developed better tanks, Germany would need weapons to defeat them. Wire-guided anti-tank missiles would appear relatively quickly, giving German infantry the ability to destroy armored vehicles at long range. Cruise missiles would be another development priority. The V-1 flying bomb, essentially a primitive cruise missile, had been used extensively during the war. More advanced versions with better guidance and longer range would be developed. These would be cheaper than ballistic missiles while offering strategic strike capability. The infrastructure to support missile development would expand dramatically. The Peenemünde facility would be enlarged. Additional research centers would be established. Testing ranges would be created in occupied territories. The program that in our timeline was dispersed among the victorious powers would instead be concentrated in Germany, likely accelerating certain developments while pursuing some dead-end paths. Space exploration would be a logical extension of missile technology. German rocket scientists had already discussed space travel possibilities. In a victory scenario, Germany would likely pursue a space program, both for prestige and for the strategic advantages of reconnaissance satellites. Whether Germany could actually achieve spaceflight before economic and political problems undermined the regime is uncertain. Armor and mechanized warfare. German tank development had followed a consistent trajectory during the war. Increasingly heavy, well-armored, and powerfully armed vehicles that sacrificed mobility and reliability for firepower and protection. This trend would likely have continued in peacetime, though eventually practical considerations might force reconsideration. The Panther and Tiger II tanks represented the apex of German wartime tank design. These were formidable vehicles with thick armor and powerful guns. However, they were complex, expensive, and mechanically unreliable. In peacetime, these designs would be refined. Reliability would improve. Manufacturing would be simplified. But the fundamental design philosophy would persist. Even heavier tank designs were in development. The Maus Super Heavy tank, weighing 188 tons, had been prototyped. This vehicle was too heavy for most bridges, had limited mobility, and consumed fuel at prodigious rates. It represented the ultimate expression of the German fascination with bigger and heavier vehicles. In peacetime, sanity might prevail and such impractical vehicles abandoned, but Nazi leadership's love of monumentalism suggests they might proceed with limited production for propaganda purposes. More practical developments would focus on improving automotive components. Better engines with greater reliability and fuel efficiency would be developed. Transmission systems, which plagued German heavy tanks throughout the war, would be re-engineered. Suspension systems would be improved to handle the weight of heavily armored vehicles. Armored personnel carriers would see significant development. The Germans had pioneered the concept with the Ballistic FZ-251 half-track. In peacetime, fully tracked armored personnel carriers would be developed, allowing infantry to accompany tanks in protected vehicles. This would improve the combined arms effectiveness of German mechanized forces. Self-propelled artillery would become standard. Germany had produced numerous self-propelled gun designs during the war. These would be refined and standardized, giving German forces mobile artillery that could keep pace with armored advances. This would be particularly important for rapid deployment to suppress resistance activities in occupied territories. Tank destroyers would continue development as specialized vehicles for engaging enemy armor. The long-range, high-velocity guns mounted on tank destroyer chassis provided a cost-effective way to defeat heavy armor. Germany would maintain substantial tank destroyer forces as part of its defensive posture. Anti-aircraft vehicles would be developed to protect mechanized forces from air attack. The German Wirbelwind and Ostwind flak Panzer vehicles would be refined. More advanced systems with radar-directed guns would appear. Eventually, surface-to-air missiles would be mounted on tracked chassis. The doctrine of mechanized warfare would continue to evolve. German armor doctrine emphasized breakthrough and exploitation, using concentrated armor to penetrate enemy lines and then fan out to create chaos in rear areas. This doctrine worked well in offensive operations, but was less suited to occupation duties. German armor forces would need to adapt to counterinsurgency roles. Naval development and maritime power. German naval development had been constrained during the war by strategic circumstances and resource limitations. Submarine warfare had been prioritized because it was the only way Germany could challenge British naval supremacy. In a victory scenario with Britain defeated or neutral, German naval priorities would shift dramatically. The submarine force would remain important, but would transition from commerce raiding to other roles. Advanced submarine designs already in development would enter service. The Type XXI, an advanced submarine with high underwater speed and sophisticated sonar, had begun production in 1944. This design would be refined and mass-produced. However, submarines alone don't establish maritime dominance. Germany would need a surface fleet. The H-class battleship designs, which called for ships larger and more powerful than any existing battleships, might be revived. These enormous vessels would be expensive and take years to build, but they would serve as symbols of German power and prestige. More practically, Germany would build cruisers and destroyers for escort duties, power projection, and securing sea lanes. Existing designs would be improved with lessons learned from wartime experience. Anti-aircraft capabilities would be enhanced. Radar and fire control systems would be installed on all major vessels. Aircraft carriers would be a priority if Germany needed power projection capability beyond European waters. The Graf Zeppelin carrier had been under construction during the war, but never completed. In peacetime, this ship would be finished and put into service. Additional carriers would be built as resources permitted. Naval aviation would develop alongside carrier construction. Germany had struggled to develop effective carrier aircraft during the war. In peacetime, purpose-designed carrier fighters, bombers, and torpedo planes would be developed. These would be based on proven land-based designs, but modified for carrier operations. Amphibious warfare capabilities would be developed for potential operations outside Europe. Landing craft and specialized amphibious vehicles would be designed. German forces had limited amphibious assault experience during the war. Doctrine and equipment for this type of operation would need to be developed from scratch. Mine warfare would remain a German specialty. Germany had been effective at naval mine laying during the war. New mine designs, including pressure mines and acoustic mines, would be developed. Minesweeping technology would advance in parallel to ensure German shipping lanes remained clear. Anti-submarine warfare would become more sophisticated as potential adversaries developed their own submarine forces. Sonar technology would advance. Depth charges would be improved. Eventually, homing torpedoes and ahead-throwing weapons would be developed. Nuclear weapons development. The question of whether Nazi Germany could have developed nuclear weapons is complex and depends heavily on the specific victory scenario. Germany's actual nuclear program during the war was modest and far behind the Allied Manhattan Project. German scientists understood the theoretical possibility of atomic weapons, but the program lacked resources, coherent organization, and suffered from the emigration of many top physicists. In a victory scenario where Germany defeated the Soviet Union in 1941-42 and achieved a negotiated peace with Britain, Germany would have additional years and resources to pursue nuclear development. However, significant obstacles would remain. The ideological environment of Nazi Germany was hostile to theoretical physics. The dismissal of Jewish physics and the flight of German Jewish scientists, including Einstein, Szilard, and Teller, had deprived Germany of many of its best theoretical physicists. Werner Heisenberg, who led German nuclear research, was a brilliant physicist but was never given the resources or priority that the Manhattan Project received. In peacetime, with more resources available, progress would be faster. However, Germany would need to rebuild theoretical physics programs, develop uranium enrichment or plutonium production capabilities, and solve numerous engineering challenges. A realistic timeline for German nuclear weapons development in a victory scenario might be 5 to 10 years after the war's end. This assumes sustained investment, successful recruitment or retention of physicists, and avoiding some of the theoretical dead ends that plagued the wartime program. By the mid-1950s, in this alternate timeline, Germany might test its first atomic device. The strategic implications would be profound. Germany with nuclear weapons and ballistic missiles to deliver them would be virtually unassailable in Europe. Any resistance movement or potential intervention would face the threat of nuclear retaliation. The balance of power would be completely altered. However, nuclear weapons development wouldn't occur in isolation. If the United States remained hostile to German-dominated Europe, the Americans would be developing nuclear weapons in parallel. The result might be a Cold War-style nuclear standoff, but with Nazi Germany rather than the Soviet Union as the Western adversary. Chemical and biological weapons would be pursued alongside nuclear development. Germany had developed nerve agents including taboon and sarin during the war but never used them, partly from fear of retaliation. In peacetime, these weapons would be refined and stockpiled. Delivery systems, including missiles and aircraft, would be designed specifically for chemical warfare. Biological weapons research would be conducted, though likely remaining more limited than chemical or nuclear programs. The difficulties of weaponizing biological agents and the unpredictability of biological warfare would make it less attractive than other weapons of mass destruction. Electronics, radar, and computing. German electronics and radar development during the war had been sophisticated but ultimately outpaced by Allied advances. In peacetime, this would be an area of intensive development as Germany sought to maintain technological superiority. Radar technology would advance rapidly. German radar had been effective, but generally less sophisticated than British or American systems. In peacetime, with access to captured technology and sustained investment, German radar would improve significantly. Both ground-based and airborne radar systems would be developed. Infrared detection systems would be refined. Germany had experimented with infrared sights for tanks and aircraft during the war. These systems would be improved and deployed more widely. Night fighting capability would be a priority for forces engaged in counterinsurgency operations. Radio communications would be improved with better equipment and greater range. Portable radios would become standard for ground forces. Aircraft would have more sophisticated communication and navigation equipment. Naval vessels would have improved radio and radar systems. Early warning networks would be established across occupied territories. Radar stations would be linked to central command facilities, creating integrated air defense systems. This would provide warning of any aerial intrusion and coordinate defensive responses. Computing development is a particularly interesting question. Germany had developed the Z3 computer, designed by Konrad Zuse, in 1941. This was a programmable electromechanical computer, one of the world's first. In our timeline, Zuse's work was largely unknown until after the war and German computing development stagnated. In a victory scenario, Zeus's work might receive more attention and resources. However, Nazi ideology was fundamentally hostile to the open intellectual environment that fostered computing breakthroughs in the United States and Britain. The emigration of mathematicians and the suppression of Jewish mathematics harmed German theoretical computer science. Computing development in Nazi Germany would likely follow the mechanical and engineering approach of Zeus, rather than the more theoretical approach that led to electronic computers in the United States. Fire control computers for artillery and naval guns would be developed. These would improve accuracy and reduce the time needed to calculate firing solutions. German fire control systems had been sophisticated during the war, and further refinement would make them more effective. Cryptography and signals intelligence would remain priorities. Germany's Enigma machine had been compromised during the war, though German authorities never fully realized the extent of Allied code-breaking. In peacetime, new encryption systems would be developed. Conversely, German signals intelligence would work to break other nations' codes. The technology gap and long-term sustainability. A crucial question about German military technology in a victory scenario is whether the apparent German advantages of the late war period would be sustainable in the long term. In several areas, German technology was indeed advanced in 1945. But sustainable technological leadership requires more than individual breakthroughs. It requires robust scientific infrastructure, resource availability, and open intellectual environments. Nazi Germany's scientific infrastructure had been severely damaged by the emigration of Jewish scientists and the suppression of unacceptable theories. The scientists who remained worked under increasing political pressure and resource constraints. In peacetime, some of these constraints would ease, but the ideological environment would remain hostile to open scientific inquiry. The brain drain of scientists fleeing Nazi persecution had been devastating. In our timeline, these emigrant scientists contributed enormously to American and British war efforts and post-war technological development. In a victory scenario, some who fled might return, either willingly or through coercion. But many of the best minds would remain abroad if possible, working for nations opposed to Nazi Germany. Resource constraints would eventually limit German technological development. Advanced weapon systems require sophisticated materials including specialized alloys, high-grade electronics components, and advanced fuels. Germany would have European resources available, but would lack access to certain critical materials available only outside Europe. This would create constraints on some development programs. Manufacturing capacity would be an ongoing challenge. High-technology weapons require precision manufacturing with tight quality control. Germany would need to maintain and expand specialized manufacturing capabilities. Labor force quality would be crucial, but Nazi policies toward education in occupied territories would undermine the broad technical education necessary for sophisticated manufacturing. Innovation requires failure tolerance and iterative development. Military technology advances through testing, failing, learning, and trying again. Nazi Germany's political environment was hostile to admitting failure. Projects that failed might lead to punishment rather than learning. This would slow technological development and lead to persistence with failed approaches longer than rational evaluation would justify. International isolation would limit technological development. Scientific and technological advancement accelerates through international exchange of ideas. If Nazi Germany was isolated from or in conflict with major powers outside Europe, German scientists would lack access to foreign research and technological developments. This would slow German progress and might cause them to miss important breakthroughs. The allocation of resources between military technology and other societal needs would create tensions. Advanced weapons systems are expensive. Developing and maintaining them requires sustained investment. This investment would compete with the economic extraction system described in the previous video and the occupation costs of controlling hostile territories. Something would have to give. Alternative technological trajectories. It's worth considering that German technological development might have followed different paths than those outlined above. Nazi ideology and strategic misconceptions could lead to investment in impressive-seeming but ultimately ineffective technologies while neglecting more practical developments. The Nazi leadership's fascination with Wunderwaffen, wonder weapons, often led to resources being poured into dramatic but impractical projects. The Maus super-heavy tank, the Gustav railway gun, and various other monumental weapons projects absorbed resources while providing minimal military value. In peacetime, without the corrective pressure of impending defeat, such projects might absorb even more resources. Prestige projects aimed at demonstrating German superiority might take precedence over practical military needs. Giant battleships, intercontinental rockets, and monumental fortifications might be built more for propaganda value than military utility. The regime's need to project power and technological superiority could distort development priorities. Racial ideology might influence technological directions in counterproductive ways. Technologies associated with certain theoretical frameworks deemed Jewish might be neglected. Practical considerations might be overridden by ideological preferences. The result would be German technology that was impressive in some areas while having serious gaps in others. Counterinsurgency requirements would drive some technological development in directions different from conventional military concerns. Technologies for surveillance, population control, and suppressing resistance would receive priority. This might accelerate development in areas like helicopter gunships, communications monitoring, and identification systems, while slowing development of technologies aimed at conventional warfare between nation-states. Conclusion. German military and technological development in a victory scenario would be characterized by impressive advances in certain areas, particularly jet aircraft, missiles, and eventually nuclear weapons, combined with fundamental vulnerabilities created by ideological constraints, resource limitations, and strategic misconceptions. In the short term, Germany would possess military superiority in Europe through sheer force of numbers and advanced weapons systems. Jet fighters, ballistic missiles, advanced armor, and expanding naval power would make Germany the dominant military force on the continent. This superiority would be sufficient to suppress resistance and deter external intervention. In the medium term, German technological advantages would face challenges. The scientific infrastructure damaged by Nazi policies would struggle to maintain rapid innovation. Resource constraints would limit some programs. International isolation would slow development in areas where cross-pollination of ideas is essential. In the long term, sustainability of German technological leadership would be questionable. The advantages visible in 1945 reflected efforts by a desperate regime under wartime pressure. Whether peacetime Nazi Germany could maintain that innovative drive while simultaneously pursuing ideological purges, suppressing education in occupied territories, and allocating resources to occupation costs is doubtful. The weapons and technologies described here represent extensions of actual German wartime programs. They weren't science fiction. German engineers and scientists were working on all of these projects to varying degrees. In a victory scenario, these projects would have continued to fruition. The result would have been a militarily powerful but technologically imbalanced Germany, strong in certain areas, but with vulnerabilities that would become more apparent over time. Understanding German military and technological trajectories in this alternate scenario reveals both the impressive achievements of German scientists and engineers and the fundamental limitations imposed by Nazi ideology and strategic thinking. The regime that could produce the Me-262 and the V-2 rocket was also the regime that drove away Einstein and suppressed theoretical physics. That contradiction would ultimately limit German technological development even in victory.